Okay, so today I'm testing, I've actually pre-tested this before, but I'm going to do a demonstration of the 1000 watt power supply from Banggood. This is the one with both controllable voltage from 0 up to 12 volt. There's several different versions of this. This is the 12 volt version. And then it's also current adjustable from 0 to 70 amps. They have several versions. I think the highest one goes up to 48 volts, if I'm correct, and obviously a lesser amperage, but it is fully adjustable. As far as both current and voltage, all the versions of this are. So again, this is the 12 volt version. We'll take a close look here. And if you can see on the top, there are some meters here. The blue one is for amperage, and the red one is for voltage. You have your power in. It can accept either 110 to 120 or 220 to 240. There's a selector on the back side. Let me see if I can turn this here. And you should see the switch on the back there. A little note of caution, the label that's on there, at least on mine, was put on upside down. So actually look at the numbers on the switch and not the paper label that was added after. The numbers on the switch will be correct. Okay, so I use this mostly for battery charging for 12 volt batteries. It's called the 12 volt version, but it will actually go up to a little over 16 volts actually. And these adjusters on here, the pots are actually multi-turn pots, so you can adjust them quite finely. So we're going to bring this up. I'll show you. We'll go up to, okay, this is open now. I've got it, the leads are disconnected. So 16.3 with no load. And I think it'll still, even under moderate load, it'll still hold about 16.2. Well more than you need for battery charging. If you can go up to 14.8, you can do a quick charge with no problem. So I'm going to set this back to about 12 volts. Okay, so, and I've got my current knob right now is all the way down. And what we're going to do is a demonstration of the amperage here to see that this actually does the 70 amps that it claims. So I've made a heating element here. This is nothing but steel packaging strap for, you know, like large cargo straps on pallets. I don't know, probably 8 to 10 feet here. We're going to connect. So I've got a full circuit here. Once the element heats, it will be just over 0.1 ohm. So now we had this set to go to 12 volts when it delivers full current. We're going to start bringing the current up. Now let's start cranking her up, see if we can get some heat here. So I'm hoping you can read the numbers here. Looks like it. So we got 30 amps, 40, we're up to 50, and we should be putting a little bit of heat out here. I've got an infrared. Let's see. The floor in here is about 7 or 8 C. And let's see what we got on this element. Yep. And when I hit it, about 40 or so far. So definitely warming up. Because that has a lot of surface area, so for that to warm up to 40 C that quick, you're definitely putting some wattage in. Okay, we got 60 amps. Okay, and I believe the fan just kicked in. So it's the unit's starting to warm. So here we are, we're at full 70, actually a little bit over. Fan's on. I'm going to back it down just a little because I don't want to overload it. But you can clearly see it actually goes in excess of what its rating is. We're running about 9 volt at 70. It's coming up because the resistance is increasing as that element heats. So now I can actually feel a little bit coming off of that. Let's see what we got for heat here. So here we got it already up to 145 C. This is Celsius, not Fahrenheit. 150. And this is on quite a big element. It's about 3/4 of an inch wide, about 8 feet long. So definitely some radiating power there. And the room in here is only about 9 C, so it's really working pretty hard. And here we are. We're still going. We're actually a little over 70 amps, 71 amps, and this is holding just fine. And the unit itself is warming up at about 45 C. It's definitely working. We're overloaded now, but it's doing it. And again, floor in here, only 8 C. Okay, I'm going to back this down because I don't want to run it overloaded for long. But definitely you can see it will push that 70 amps as it claims without a problem. Okay, next I'm going to show, we'll do a test of charging a battery with it and get to see that with the regulation. Okay, so here we are. This is part 2. We're going to do a demonstration of battery charging. I know some people have asked about doing that with this unit. It's definitely the main purpose of what I bought it for, though I do use it for other things. So let's start this up again. And just a little note, this is a Pontiac Fiero that I converted to an electric car, so the layout here is a little unusual. The battery in the front just runs my system controls, and main batteries are in the back, but that's a whole nother story. Anyways, we've got this started, and I'm going to set this for normal charging at for quick charge at 14.8 on the voltage, which is a good quick charge, which isn't going to damage your battery. And we'll start with the current down, and we'll make the connect here. Okay, so we have a connect, and with it not being able to push any significant current, you can see this battery is definitely drained. It's only 9 volts. So let's start turning this up, and as long as I don't exceed 70, which it's not going to do on a battery like this, I must have bumped the voltage just a little. So we get about 15 amps charge here or so, and it's coming up because the resistance is going down as it takes a little charge. But okay, we're pushing 16.2 amps here, so a pretty significant charge. Now here's the question though that a lot of people have is certain power supplies, if you disconnect the power, the input power to the power supply, and it's still connected to a battery, you can on some units it can damage the unit. A lot of your buck boost type your voltage converters. They, you know, take current and change it for voltage, for changing the ratio of voltage to current. These are notorious. If they don't have a diode in the back of it, it will oftentimes burn them up. If you disconnect the input power when there's still output, like a battery, connected to the output. So we're going to leave this hooked up, and I'm going to unplug here, and we'll see what happens. So we're unplugged, and you can see the voltage has gone out. And we'll see, so it may stay flickering a little because there's some current coming in from the back, but no, it's going out. So the input is definitely shut off. I'm clearly unplugged here. We're still hooked up to the battery, and let's plug back in and see what happens. So here we are, and it's come right back, and voltage has gone right up to 14.8, and we're actually taking even more current now at 19.7. So clearly this works okay for battery charging. You can have it set up where you unplug it and it's still connected to the battery, and it's not going to damage it. And indeed, I've done this quite a bit before. I'm just doing this for demonstration here. And the nice thing here is, because it has current control, if I don't want to exceed, you know, like 20 amps or 15 amps, I can back this off and limit it. So let me keep going here, and see here, we can limit this to so it doesn't exceed the 15 amps, and you'll see the voltage goes down now because it can't push enough to the amount of current the battery wants to draw at 14.8 is more than I'm allowing to go to it. So as a result, the voltage drops until you get a charge on the battery. And at 14.7 here, it's going to take a continue to charge, and eventually that voltage will come back up. Limit the current. You can turn it up if you want. If I bring it up, and you can see the voltage starts going up again. You can set your voltage independently so you can have a peak, so you don't damage your battery from overvolt when it's finished charging. If you're doing a trickle charge, you can set the voltage back. I typically, for a trickle charge, I'm going to do about 13.6 to 13.8. Tune this in here, and then turn your current down. For a standard car battery, probably nothing more than about 2 amps, and that'll give a nice slow, gentle charge on the battery to revive it, and it'll peak out at 13.2, and it won't exceed that. You can leave it at 13.2, I mean not 13.2, but 13.8 or 13.6. You can pretty well leave it connected indefinitely, and it's not going to hurt the battery. If you're doing quick charge at 14.6 to 14.8, well, then you can start boiling the battery down if you leave it on too long. So those kind of voltages are really just for getting it charged quick. You can also do this for lithium. Just be real careful not to overvolt or overcurrent. Make sure, particularly on your voltage, that it's not going to exceed the cutoff voltage on your lithium battery. And different chemistries of lithium have different voltages. But if you do let them run over voltage of what they're rated, they can burst into flames. So be aware of that. But this charger is definitely capable of doing it. And the higher voltage ones, if you have like a bank of batteries, really should be no different than this, other than you're trading off your current capability for a higher voltage capability. So I think that pretty well concludes for this segment.